All right, we were asked to find, at least in part A, the plane in standard form spanned by the vectors u2 and u3. As a refresher, a plane in standard form in R3 has the form ax plus by plus cz plus d is equal to 0. And we want to find the values of a, b, c, and d that define the plane that u2 and u3 span. As we know, any two linearly independent vectors in R3, meaning any two vectors in R3 that don't point in the same direction, span a plane. The key that a lot of students, while taking this exam in fall 2025, missed is that we gave you the fact that these three vectors are orthogonal. That's stated in the question. What does that mean? Well, it means if we're looking for the plane spanned by u2 and u3, the coefficients a, b, and c in the standard form equation of the plane can be taken just from reading off the coordinates of u, meaning that the plane we're looking for is 13x minus 3y plus 2z equals 0. Why is that? Well, first, let's automatically deduce one of the four coefficients we're looking for, a, b, c, and d. We know that d has to be 0. Why is that? Well, it's because the span of any vectors must contain the 0 vector. And you would get that if you took 0 of the first vector plus 0 of the second vector. And remember, the span is the set of all linear combinations of the vectors you're starting with. So if you want to contain all linear combinations of the vectors you're starting with, in our case that's u2 and u3, the equation we produce should satisfy the 0 vector, or should contain or be satisfied, by the 0 vector, which means d must be 0. Then the question is, well, what must a, b, and c be? The way that you've practiced finding those coefficients a, b, and c is by taking the cross product of the vectors that span the plane whose standard form equation you're trying to find. Right? So what you would do is you take the cross product of u2 and u3. Why is that? Well, the point of the cross product, which is only defined for vectors in R3, not R2, not R4, not R5, just R3. The point of the cross product is to take any two vectors and return back a vector that is orthogonal to both of them. Okay? That the cross product doesn't require that the original two you started with are orthogonal, they just happen to be here. But the cross product returns you back this vector, the one that's that is orthogonal to both of the original ones you started with. Why is that relevant? Well, it's because if you look at this formula, ax plus by plus cz equals 0, all you're really doing is taking the dot product of the vector x, y, z with the vector a, b, c. Right? If you take a closer look at this, this is really saying take the dot product of the vector a, b, c with your vector x, y, z. And the fact that that's 0 tells us ABC must be orthogonal to x, y, z. So really we're just looking for numbers a, b, and c such that when you dot this with either of the vectors you're starting with, so we could put a 0, 4, 6 here, or a 1, 3, negative 2 here, in both of those cases, or in any linear combination of those vectors, you get a 0. That's what the cross product usually gives you. It gives you the a, b, and c. The reason you don't need the cross product here is because the question told you that all pairs of these vectors are orthogonal, which means if you put 13, negative 3, and 2 here, well, this is 0, because the vectors are pairwise orthogonal, and it would be 0 if you put a 0, 4, and 6, which is u2 here. What this tells you is that the coefficients you're looking for are just 13, 3, and 2. Now, if you did the cross product, would you get this vector exactly? No, not necessarily. All that's guaranteed by the cross product is that you get some vector along this direction. But which specific one you get has to do with the length of u2 and the length of u3 here. And it has some physical interpretation that sometimes they care about in physics and electrical engineering, but we don't really care about that for our purposes. All you get back is some vector in this direction. So either you're going to get 13, negative 3, and 2, or some scalar multiple of it. But you could just divide by whatever scalar multiple you want to be able to rewrite it in this form. Just to see it worked out, we can do the cross product way, although the takeaway of this video should not be, okay, I could do it the cross product way. Know that you could, but often we will give you clues to make computation a little easier. Sometimes there's an easier way and a hard way to do it, but they should always give you the same answer. What is the cross product of the vectors in question? Well, we have 0, 4, and 6, and we're taking the cross product of that with 1, 3, and negative 2. The first component of the output is going to be 4 times negative 2 minus 3 times 6. So I'm going to get 4, negative 2 minus 3 times 6. Okay, what's the next component? I think I'm going to get a 6 times 1 minus 0 times negative 2, which I think looks just like a 6 times 1. And then finally, I'm going to get a 0 times 3, which is just 0, minus 1 times 4. Okay, do some simplification here. 18 plus 8 is 26, but they're negative, so I'm going to get negative 26, 6, and negative 4. So is that the same vector as I started with here? No, but they're related. This is just negative 2 times that vector, right? This is 13 times negative 2, this is negative 3 times negative 2, and this is 2 times negative 2. So this is just negative 2 times u1, okay? I knew it was going to be something times u1 because the question told me these 3 vectors are orthogonal. What I didn't know is that it was going to be negative 2 times that. But if this is what I found and just wrote down negative 26x plus 6y minus 4z equals 0, and I circled that as being my final answer, that would have earned full credit. Don't get me wrong. I'm just saying you could have done this an easier way, which is recognizing the vectors were orthogonal. Okay, so that was part A. Let's clear some space here. Part B of this question didn't involve this plane. Instead, it involved projection, okay? And in that part, what we were given is some other vector, x, whose components were 7, 3, and 1. And what we were told is that there is a value of k such that the projection of x onto u subscript k, so k is either 1, 2, or 3 here, because we have u1, u2, and u3, is uk itself. So for one of these, let me put that in slightly more interpretable terms. What we were telling you is that for one of these 3 vectors, if you project x onto that vector, the projection is that vector itself. What do I mean by that? Well, usually when we project x onto some other vector, the result will be some scalar times that other vector, right? The variables that we are used to involve u and v. And if I were to draw this picture, the projection of u onto v would be, I don't know, this is maybe 33% longer than v, so maybe the projection of u onto v would be 4/3 v, right? And we spent a lot of time in class trying to figure out what is the optimal amount to multiply v by so that it most closely approximates u, right? And there were several ways we arrived at that. There was the orthogonality argument. There was the calculus way you did in homework 3. What we're told in this question is that for one of these 3 vectors, u1, u2, or u3, when you project x onto that vector, this scalar is just 1. So it's not some other number times the vector you started with, it's just 1 times that vector you started with. So really for one of these 3 vectors, that optimal coefficient, whose formula we're going to have to remember in a second, is just 1. Which vector is it? Well, let's figure that out. What is that coefficient? That is in the formula for p, what is the coefficient? Well, it's x dotted with the vector you're projecting onto over the vector you're projecting onto dotted with itself. So the way we've seen this is u, v, 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 but x is our u here, and uk is our v. And then this would be uk. So we're looking for which of these 3 is such that this coefficient up here is 1. Now one part of this question that's a little confusing, and I should have worded this differently when we first made the exam, is that in class, we called this number k, right? So k is a little ambiguous here because for this question, k is either 1, 2, or 3. It's the index of these. but I should have used I instead of k in this question because k to us meant the value for the scalar. Anyway, so now this just boils down to an algebra question. For which of these three vectors is x dot that vector equal to that vector dot itself? Because if the numerator and denominator are the same, well then this fraction will be equal to 1. We can do some algebra. Why don't we start with u1? So what's x dot u1? I think we're going to get a 13 times 7. Oh, I got to do mental math on the spot. I think that's 91 minus 3 times 3, which is 9, plus 2. I think that's 84. And what's u1 dot u1? I think we're going to get 169 plus 9. Okay, I don't need to do any more math because this is going to be bigger than 169, so it's not going to be this one, right? Because I would need this to be equal to 84 for x dot u1 over u1 dot u1 to be equal to 1. So I don't need to proceed any further. It's not going to be u1. Okay. Let's try again with u2. What's x dot u2? That's going to give me 7 times 0, which is 0. I like that. 3 times 4, which is 12. And then 1 times 6, which is 6, which is 18. u2 dot u2, what is that? 0. 4 times 4 is 16. 6 times 6 is 36. It's not this one either, because x dot u2 over u2 dot u2 is going to be 18 over 52. That's not 1. So if we did everything correctly, the answer should be u3, or else we did some algebra wrong. And we should still verify that, right? X dot u3, 7 plus 9 minus 2 looks like 14. And u3 dot u3 is 1 plus 9 plus negative 2 squared, which is 4. That looks like 14. Lovely. So now x dot u3 over u3 dot u3 is 14 over 14, which is 1, which means when we draw this picture, and we have x up here, u3 down here, when you project x onto u3, so that is if you stand up here and say, hey, what is the shadow of x onto u3? It is u3 itself. Not a little bit more than u3, not a little bit less than u3, u3 itself. And so the answer was k is equal to 3. Let us know if you have any questions with this problem from Fall 25's Midterm 1.